So I had this problem where my garbage can lid broke because this like bolt thing that goes in there snapped. That piece right there. So I designed a replacement in Fusion 360, iterated one design, printed a final, and it works perfectly. A couple people were interested in how I designed this in Fusion 360, so I'm going to give a crash course in how I did it. So this is the end result of what I printed. It works perfectly so far. I have no idea how long it'll last, but hopefully a long time. So first, I'm just going to give a crash course in a couple of basic Fusion 360 concepts that I think will be helpful going into it. If you already know the very, very, very basics, you could jump a little later to when I get into actually making the piece. I'm not I'm a beginner in Fusion 360. I learned it just a couple months ago. I've made like 5 things in it. Like I really, really, I don't know what 90% of the things in this interface do at all. But so maybe that'll help show you that you don't need to be an expert to actually be able to use it to make things. So in Fusion 360, it's parameterized design. And what took me a long time to wrap my head around is that I kept thinking of it as like Photoshop. You know, you'd be like drawing and modifying it and using a bunch of tools and drawing on top of it and stuff like that. I don't. I no longer see Fusion as that at all. I see it as a series of mathematical equations that you tell it, or operations that you want to do on your model, and then it computes the end result. And hopefully that'll become more clear in a moment. Let's just talk about how you make very basic things in Fusion. Most of the time, when you want to make something, is first thing we do is we create a component. I actually don't know why we create a component. I learned this months ago and forgot. But I'll say that what I remember learning is that it's similar to making a branch in Git. You do it first because later, if you need to have had a component, it will be really annoying if you didn't do that as your first step. Exactly the same as making a branch in Git. So just make one and then don't worry about it. And now that component is active with this little dot. That means everything I'm now doing is inside that component, which is what we want. So first things first is we make a sketch. You click this create a sketch button and you're already confused because you're like, oh geez, what's going on? So all you're saying is what plane do you want to draw the sketch on? Because it's going to be a two-dimensional sketch. So I'm just going to click on any one of the planes, and now I'm sketching. Now it didn't actually pull my camera facing that way. I think it used to. I may have changed an option, but you have this little widget up here that you can always click to like jump to the side that you're on. So here is what I'm going to do. So I'm going to use this line tool in sketching, and I'm just going to start with the origin, and I'm going to like make a triangle. Okay, and I'm going to click finish sketch. Now that's a two-dimensional thing, and now we want to make something three-dimensional. So what you do next is you're typically going to pull that into a three-dimensional shape in some fashion. Oftentimes that's through extruding. There's a reason it's the very second button. So extruding simply means that you're going to pull that sketch, and now it's a three-dimensional object. Right? So, and there's a bunch of options over here whenever you're using one of these tools. So I did extruding from one direction, but I could do a symmetric one where now as I pull, it's going in both directions. And by default, it's going to create a new body when I do that, which is what I want to do now. But you can also extrude as a cutting tool, or you can extrude and join it to an existing body. But for now, we'll just do that. Now we have this prism, right? So that's like, okay, now we've made a shape in Fusion. And why is that different from other things that I've used, or my assumption that it would be like Photoshop? Like any other tool in the whole world, you have this history bar down here. Actually, let's do another operation on this thing. So I'm going to modify this thing one more time by selecting a face, and I'm going to use one of these modify tools like Fillet, because that's kind of a fun one. So I've got Fillet here. I'm going to drag this here. Whenever you're dragging, you're also the numbers here. Like I could type it in if I knew how much. So I'm going to fillet this, which is gonna do that. Okay. Now my shape is looking really funky, right? And it kind of acted a little weird because it was a rectangle, not a square. So we've got this. But let's say, on the very first step, I screwed up, and my triangle needed to have been a totally different shape. Well, down here in the history, you can drag your little history bar back to go back in time. That's nothing special, right? This is back before I extruded it. Oh, something that you're noticing here is the sketch is invisible. When after you extrude with a sketch, by default, this is your hierarchy up here of your project. So if I expand my component, I have sketches and bodies. This is the body. This is the sketch. The sketch became hidden. Fusion does that automatically after you extrude or turn it into a three-dimensional object in any way, just because usually that's what you wanted to do and you don't want to see it anymore. So it's convenient, but if you want to see it again, you got to toggle it back on. So I can go back in time and see the sketch, right? But notice that when I'm back in time here, oh, never mind. The thing I was going to say is not true, so ignore the thing I didn't say. But let's talk about how this is different, where if I double click on this sketch here, I can edit the sketch again. And I can go and maybe I want the triangle to be much more like this, and I want, let's not do that. Yeah, let's make it like a much sharper triangle and do finish sketch. Now, I'm already looking at the finished product as if that was the sketch I had done from the very beginning. When you modify something in the history in Fusion, you're modifying the parameters of that operation, and the future things you did on the shape are still there. So the fillet makes it a little hard to tell that it's going all the way to that end, but if I undo the fillet, for example, we can see that's the prism that it made. It's the long triangle now. And if I go back and edit the sketch again, I could change it completely. I could add a how do I do this? Actually, I don't know how to break this into another piece. We'll get to that in a moment. But if I if I changed it completely and made it like that, now here's my prism. And if we go back to what it looks like with the fillet, there it looks like that, right? So that's like the first sort of mind-blowing thing to me that didn't make sense to me. I've never used any other CAD tools before, so I was not familiar with any of these sorts of principles. And it's the thing that took me the longest to figure out, is that Fusion is just computing a series of operations and giving you the end result. And once I wrapped my head around that, figuring out how to make things in it became way, way, way easier. Let's jump back for a moment. Let's actually delete these. So if you go back in time, here's another important thing to know. If I go back in time and do another thing to this face, like press pull, I actually don't know what this does. Oh, it just sort of changes the shape there, and then press OK. The fillet thing is still there. The fillet operation still happened. And if I go back to the present time in history, that's now what it looked like after I pressed the face and then filleted the face. So when you go back in time, it's not like Photoshop, where if you go back here and then do something, it wipes out the future. You're just inserting a new operation in there. So if you don't want to have done any of that, you actually have to delete. You got to delete what you don't want, right? So that actually, it gave a warning because I deleted something that a future operation depended on, so it warned me that it was going to delete the future operation. Let's talk about one other way that you can. There are lots of ways that you can create a shape from a sketch, but I'm going to talk about the only other one I've ever used, which is the very third button up on the interface, which is Revolve. So Revolve, instead of extruding, which pulls a sketch out, Revolve spins a sketch around an axis to create a three-dimensional object. So when I use the Revolve tool, first it's having me select the profile. This was already selected because it was selected when I pressed the button. And then it's asking me for the axis. So for the axis, you can give it a world axis, like these X, Y, Z's here, or you could select a part of a sketch or anything else that it lets you select in the design. So let's just imagine, let's revolve it around just the vertical axis, the Z axis. And then click, what are we doing? There's an error. Oh, there's an overlap. I can't revolve it around that because it's on both sides of the axis. So instead, let's pick this line here. If I had kept it as a triangle with a vertical line, it would have worked. But so let's use this as the axis. We can see what we have is now a cone. Because if you imagine, it's not just, actually, it's not a cone. It's a cone with this little, I don't even know what you would call that. I'm failing high school geometry here, but whatever. It's got a hollow area here because that shape revolved around that. And so now I have this body that is that shape. So that's the very, very, very basics. Let's jump into making this thing. So I'm just going to go ahead and wipe that whole thing out and not save it, and click up here for new design and start from scratch. So When I was looking at this piece, which I'm holding here as well, because I'm going to do some real world things that I will show you. Let's jump back to that and let's put it over here. I was looking at how would I create this from scratch. And so what I was saying about visualizing this as a series of operations is really important for figuring out how you want to start. So when you look at this thing, the most important thing to realize is that it is entirely a revolved silhouette around the middle axis. There are cuts in the middle here that make the that let it bend in the top, and that's how it like pressure clips into the end. But let's ignore that for now because we can cut that out later. What we want to concentrate on now is if we just make this silhouette here, the edge of it, we can then revolve it around, and we'll get this shape. So how I got started with that was I'm going to put it on this axis here. Again, it didn't move my camera, but there we go. And the way I did this, just because it worked for me, was I decided to just freehand make the shape. The dimensions are going to be completely blown to hell. It's not going to be the right thing at all, but it will still work. So I just use the line tool. So I'm going to start right here. This is going to be the bottom middle of it. So while the original is actually rounded on the end, since that's where it's going to sit on my print bed, I'm just going to have that be flat. Also, I think it's just for aesthetics, so it doesn't really matter. So mine's flat on the end. So I'm going to make it flat on the end. And we see that goes out kind of far. That's that little bottom bit there. Then it goes here, and it's got some amount of height. It goes in more, like a little bit. And then it goes in like just a teeny tiny bit and goes here, and it goes in a teeny tiny bit again. And then it comes out. Oops, I'm going to zoom in to get a little more control. It goes out a little bit again. Oh, hang on, I got a constraint that I didn't want. Actually, we'll leave that there so we can talk about it later. And then it goes out some more, and it comes over this way a bit more. And I think this is where it goes like this, and it does a slope in this way. And then it goes up to the end. I'm going to make the tip flat here just for ease, and I'll show you why I'm going to do that later. And then it goes all the way back to this axis here, which I was hoping it would snap to, but it's not. I'm just going to get it as close as I can because I can fix it later. And then I complete the shape. Okay, so I've now made this freeform shape here. And in fact, just to see how it looks, I'm going to finish the sketch. Now I have this thing that is totally the wrong dimensions, but it doesn't matter. Now we're going to go ahead and so we can see it in 3D space. I'm going to do that same revolve tool around this axis. There it is. That's my thing. Looks exactly like it, right? Not at all, but it's the right basic structure. And I'm going to go ahead and make it. So here we go. That's it. Now we just need to go back and fix the sketch to be accurate. Now, I want to talk about some of the things. There's like a lot of icons on the screen. And understanding what these are is pretty important for working with sketches and not getting incredibly frustrated, because it's going to do things that are unexpected if you don't realize what all these little icons are. So when you make, let's, for the sake of talking about this, let's just make a rectangle over here. And let's look at what happens when we make a rectangle. You always press enter to finish an operation, or alternatively, you can right click and there's an OK or a cancel there. Right click is just a shortcut to like things that are elsewhere on the interface. Just if you get stuck, but you should definitely watch a tutorial on the basics of the Fusion interface. What actually happened here when we made a rectangle was it created 4 line segments. So remember high school geometry, and a line segment is just a line in between 2 points. What's interesting here is if I click on this point, there's a little icon here, and what all of these icons are is they are constraints. They are parameters for this sketch that Fusion will not violate. If I go and grab this side, it lets me go left and right, but it doesn't let me go up and down. Why is that? Well, I made it as a rectangle, but how does it know that it wants to always be a rectangle? It makes some assumptions when you make sketches that are usually right, but not always, because it can't read your mind. So these icons right here, these are vertical horizontal constraints. I believe that's what it's called. Yeah, this is called a horizontal constraint. It is saying that this line segment here must always be perfectly horizontal. And same with this one, and these two side ones have vertical constraints. Furthermore, if you click on a point here, this one's kind of interesting. There's a constraint here called coincident. What that really means is if I drag this point, notice how the whole shape moves. You could think of it as, well, I'm grabbing the point that those two line segments end in, but technically those two line segments each have their own point. And the reason it moves together is because the end of each of those segments has a coincident constraint, meaning it should be on the same point. If I delete that coincident constraint, you can actually click on the icon and press delete. When I drag this now, suddenly I've broken the shape because these 2 points are no longer a coincidence constraint. And I can remake that as a coincident constraint by dragging it over here. Well, let's talk about how you actually make a constraint. It's having trouble getting to where I want it to be, but that's okay. What I'm going to do is I'm going to select one of these. Up here, this entire section here is the constraints. It's got most of them here, or maybe all of them. Oh, they're all there. So the coincident constraint is this one. If I click here and then click on the other point, I've now created a coincident constraint, and oops, I finished my sketch. That was an accident. Let's get back in there. There we go. It recreated that coincident constraint, and it moved the lines in order to make that possible. So that was just a crash course on what constraints are, and so we're going to delete all of that and go back to this. There's a lot more constraints that we see here. This is one of the most common constraints right here, which is it's a perpendicular constraint. I also think of it as a right angle constraint, right? So what it's saying is these two lines here are perpendicular to one another, and it will never violate that unless I delete that constraint. Notice that up here, for this sloped line, there is no perpendicular constraint because it's not. It also did not make a perpendicular constraint at this corner because if you remember, I had to freehand place it and it didn't actually end up on this axis. Now's the time I can fix that. I intended for this to be a horizontal line. No problem. I can just go up and add the horizontal vertical constraint. It's gonna pick horizontal or vertical based on what it's closest to being. So as soon as I click that, it's now vertical, and it's done. So now this does happen to be perpendicular. It doesn't have the constraint there. I might not need it. Well, actually, I'm going to go ahead and add a horizontal constraint to this one. Oh, hang on. I don't know what I'm doing. There we go. Well, let's not worry about that for now. So I've got this shape. Let's talk about inputting the dimensions here. This was completely freehand, but now I want to start doing some measurements. So to clone this, I need to know the dimensions that it needs to insert into the garbage can. For that, I have digital calipers. These are absolutely critical if you want to make something that fits into something else that you already have, because you need very precise measurements. So these are digital calipers. It's got a zeroing button, which also comes in handy. That guy right there. So all I got to do is go here, and I measure here. It's a little hard to measure a rounded shape because you could have it. So the old phrase, measure twice, cut once. I measure like 40 times here just to make sure. I rotate it around, make sure I've got it. And then it says I'm at 21.97. We'll call that 22. That's well within the margin of error of this tool. This measures within 1/100th of a millimeter. I don't really trust it to 1/100th of a millimeter because I can just actually apply pressure against the metal and it changes the measurement. But the 1/10th of a millimeter is probably accurate. I've already forgotten what I said it was. It was 22. So here's how I put that into Fusion. You can apply another type of constraint. I guess it's not technically a constraint, but it's called a dimension. And that is, I'm going to input the dimensions of a particular part. So that's this tool up here. It's also the D key. So you push it, and you basically press on the line. You click on the line that you want to give it a dimension. And I measured this. I measured from here all the way to the other side, the imaginary other side that we don't have in this sketch. So I'm going to do this very bottom line. It'll be the flat bottom of this whole thing. So what I do is you click there, and now you've got this. Where you place this is just for aesthetics. It's just wherever you want it to be. It's right here. And, oh, look, this is only 7 millimeters, so I was way small. I put in 22. Boom. Now that is 22. And the reason I called it a The reason I called it a constraint is because now Fusion won't violate this. This is locked in when I go to try to move things. So if I try to move this point, I can't move it left and right because 22 is locked in. And there's another constraint I didn't talk about. When I started my sketch on this origin point at 0, 0, by starting it there, it created I think it's a coincident. Well, it locked it to that point. I think there's a coincident constraint there to make that happen. So now this is locked in at 22, except I made a mistake, which you may have already noticed. 22 was the entire diameter. I actually want that to be the radius. I don't have to do the math myself. I can put in a formula here. So that way I know this is the original measurement I took, 22 divided by 2. Now it becomes 11, but the formula is still there. Okay. I didn't say this in the beginning. I'm working in millimeters. It's really important to, up here in your hierarchy, to expand your document settings and make sure the units is set to the unit type that you want to work in. Because you can type everything here without units, but it will use whatever the document's units are. So make sure you set that. You might need to set that in the beginning. I don't know if I change it now, I don't know what happens. So do that first, even though I didn't. It remembers, I'm pretty sure. It's just always been millimeters for a long time now. So now, how do I set the constraints for the next area? So let's say I take the measurement. I'm not going to get accurate measurements here because it doesn't really matter for this tutorial. But okay, so I'm going to go and measure this next little bump in, right? And so it's 15-ish. So let's call it 15. Well, I don't have a line to work with that goes from this wall to the middle. That's what I want to input 15 as. So what I can do is, Alexa, turn on the family room. Sorry, my auto off. What did that happen? Oh, because I quit Steam. Anyway, I don't have a line from here to here. So all I have to do is make one. So right here, when you're drawing a line, you can see another constraint icon. See when I'm in the middle of the line, it makes the triangle? The triangle happens to be the midpoint constraint, just because it's nice and pleasing to my symmetrical sensibilities. I'm going to start there. I'm going to go over here and see how it kind of snaps when it's horizontal. It wants to help you do what's obvious. So I'm going to go from here and then go there. I now have a line, but I also have a problem because now my shape is separated into two, and I didn't want it to be two shapes here. I just wanted this just for the sake of measurement. Well, Fusion has a concept for that. You click this line, and you can right-click it, and it's this thing right here called normal/construction. It's a toggle. So everything here is normal. There's also a button up here that does the same thing. Fusion has a lot of ways to do the same things. It's also X, which I use this a lot, so I use X a lot. If you change it to a construction line, it no longer has what you might think of as a physical meaning in the sketch. So it no longer divides the shape in two. It is there strictly for construction purposes, which is what we want. So now I can use the dimension tool again. So I'm going to press D. Since I already had it selected, it was already there, and I'm just going to put it right below it. And now I said this was 15, right? This time I'm going to remember to divide by 2. Now it goes 7.5. So what I did was I put a construction line that's bound from here to there, and then gave it a dimension, and now we have the next step down. So let's just pretend this next one was 13. I'm going to do the same exact option. I'm going to press L, create a line from here to here. Then I'm going to push dimension to do that, and then we're going to call this one 13, right? And then we do the same thing here, from here to here. I'll give you a little tip on this next one, since we're not going to do this whole thing. Instead of saying, okay, I'm going to do let's say this one's 11 divided by 2. Let's say if what was important to me was that it was 1 millimeter less than this one. Well, while my cursor is in here, not my cursor, but while my text input is in there, I can also just click on another dimension, like this one. That dimension happens to be named D4, because it was the fourth one I made. And then I can go -1. So this, and see how it says fx, it means it's a function. So this is 1 millimeter less than this. And if I go and double click this to modify it and say, no, this was actually 12 millimeters in diameter. Now that adjusts dynamically there. So I could go all the way up the line here and go from here to here and then do a dimension on that one, and I'm going to call that, we'll say this is here, but +1 again. Oh, whoops. Oh, that actually did work, but that was not what I wanted. Let's go minus, because that doesn't look right. And we could go all the way down. I'm not going to do every part of it because we're not actually trying to make the full thing here. But let's say this part definitely needs to be bigger just for the sake of doing the next part. And this should be like here. And so now I'm just free dragging it, which wouldn't get me, accurate results. But okay, there we go. So now we've got, something that's more approximates the thing. Let's make the end a lot longer. And here. So what I did for the dimensions on this diagonal shape was I used the calipers and measured I did measure the diagonal length there. And because I also had this length constrained and this length constrained, it all worked out because there was only one way it could solve for that. When making dimensions and constraints, it's very easy to make too many. You only want as many constraints as necessary to define the shape. If you put too many, you'll start getting solving errors where it can't figure out how to reconcile everything you've put in. Maybe you made a mistake. Maybe you just made it too complicated. So there's a whole science to what you should actually give dimensions and when you shouldn't. I'm not an expert on it. I have no idea, but I just did it for all of the changing diameters up and down this whole thing, and it worked. So if I finish my sketch now, again, we can already see here is the modified shape. It is a far cry from the real thing, but if I had actually input all of that in, it would have looked right. Because the big thing I didn't do in this example was I didn't do any of these dimensions. Actually, and I also forgot to make each of these lines that I did, construction lines. Notice that it still worked because while these are discrete shapes now, you can still, when working with the sketch in 3D space, you can still select the whole object. But it's a little nicer to have these as construction lines so that they don't, it's just more semantically true. And I'm sure it has ramifications and things that I don't understand. So what I didn't do is measure the height of each of these sections. So I would do that and need to do this. So let's say this is actually supposed to be 2 millimeters. Now, notice because I made this 2 millimeters, over here we've got a shape that doesn't look at all like what we had. So I would just want to drag this back up above, and before I've got the dimensions put in, maybe I just want to kind of do this just to keep it more organized in my head. But see, it's keeping all of the constraints and everything's working. In fact, you can see because of the combination of constraints going here, it's doing a sort of odd thing where it's moving that line when I move this line. And that's because of the combination of constraints. That has to be true. I'm not sure why in that particular case. I think it was pivoting around this midpoint or something like that. So that's why, it can be a little confusing when it's doing things, but just remember it's solving for how to make all these constraints stay true. So once you input all of these dimensions, I'd put this one here. Whoops. I'd put this one here. Maybe this is only a 0.5 millimeter. So I'd go 0.5. I'd go all the way up and do all of these dimensions that are necessary, and then finish the sketch. So I said I was going to make the top flat and come back to that because in my final, it's not flat. Instead of making that curve in the sketch, which I could have done, but I don't really know how to use curves effectively in the sketch, I just went ahead and used the fillet tool that I talked about in the very beginning to fillet the end. The only reason the end is rounded is just to make it easier to insert into the hole. So as long as it's got some fillet, who cares how much it actually is? That was my philosophy. So that was fine enough. And now that fillet action is here. And if I ever want to change the parameters of the fillet, I can double click down here and now I can change how much I filleted it. So that was the basics there. I'm a little hesitant to talk about how I cut the plus in the end here. There's a couple different ways I could have gone, but I'm no expert here, and it was really messy the way I did it. But I started with thinking I should draw a sketch against this face as a plus, and then extrude it down as a cut. In fact, I can at least show you how we would do that if we wanted to. Real quick, because that's very easy to demonstrate. So I just clicked Create New Sketch, and I clicked on this face. So I now have a new sketch that's being drawn directly on this face. And what we would essentially want to do is do a rectangle like this, except we want it to be bigger. Here we go. Oh, see, this is where some stuff gets a little confusing when you're sketching against faces. The geometry of the face that I'm on is actually having an effect on my sketch. There's like settings you can set that turns that off, and probably some of these checkboxes affect that. I don't know how any of that works. I just bumble through it. But anyway, look, now I have a rectangle that's here. That's good enough. I can finish the sketch. Now, I didn't actually take the time to make sure it's centered on that axis. Let's go back and do that just because that's pretty important. The way I would do that is, how would I do that? I think I could have, see, what you have to do is like wrap your head around the constraint that would make that possible. If I had, oh, I know, I could put a line from the midpoint here to the midpoint here, make it a construction line. There's the whole line, make it a construction line because I don't actually want it to divide the shape. And now I'm going to put this line on, I'm going to make it a coincident on this axis, the red axis. But I can't actually select the axis, so I don't know how. Something along those lines would do it. I could probably have, here we go, the origin, which happens to be the middle, and there's my line. So I'm going to make the origin the midpoint of that line that I put across, and that should basically do what I want. There we go. So that's one way to do it, because I'm now that middle line, we know it's in the middle of the rectangle because it's on the midpoint of the ends, and it also means the rectangle is perfectly centered in this axis. What is that? The x-axis, because it's on the midpoint of that subdivided line there is on the origin point, which happens to be the very middle of this circle. So that worked. So we're going to finish the sketch. Now we have this sketch here, right? So if I double-click that sketch to select the entire shape, I can now extrude. And here is the really cool thing. So I'm going to, it actually didn't work. I got to select it again. So here's the thing. Because I didn't fix this, dividing it into 3 shapes, I got to select all 3. But hey, it still works to just select all 3. So I should have fixed it if I was doing it right, but it doesn't matter. So now I'm extruding right now, but that's not what I want to do. Over here, the operation, I want to change it to cut. So now I'm extruding as a cut. So as you can see, when I'm dragging down, it's cutting the object. So I would need to measure with the calipers to go how far down, but it's something like whatever, that far, right? And that's it. I click OK, and now I've cut the thing. That's like really close. Now I just need to make one that's vertical and cut down that way. Now I did all that. That's not how I ended up doing it. It would have worked fine if I had done that. The way I did it, I'll just go back to my original thing here. And you should also name your sketches and bodies, by the way, because it makes it easier later. But I didn't do that here. I have this sketch here. I sketched it against this axis instead. The reason I did that was when I was looking really closely at this clip, it's hard to tell because this has been in the garbage can for years and years and years. And so I can't tell if the plastic's been like permanently bent from its original factory position, or if there's a tapering of the cut from here to here. It really looks like I've tried to like bend these back and look at it, and I'm pretty sure it's rounded at the very, very bottom here. The camera's not focusing. Whatever, you can see it in this picture, kind of. I think it's rounded down here, and then it tapers inward, and then it's pretty constant going up the rest of the way. I'm not a mechanical or structural engineer or even know what the name of the discipline is that would study that sort of thing. I'm sure someone that actually does this would know exactly the way you should taper it for structural stability and stuff. I went and just made it a rectangle, and I tried it, and it worked, so I left it that way. Always try, because you can 3D print something so quickly to test it. Maybe you don't need to make it more complicated, but it would probably be stronger if I did it correctly, is usually the reason these things are done, or for cost savings. So I just did it as a rectangle, but that's the reason I did it against this face here, was because if I needed to make it a different shape, in fact, if we just hide this body to make it, like I could have, this whole line here could be curvy. I could have done something like this, right? And then had this shape that was like, whoopsie. And then I could have, and I could have cut it in this shape, except actually what I'd want to do, right? It would be like tapered inward or something like that. It turned out I didn't need it, as far as I can tell. We'll see how quickly this clip breaks again. But so I just went with rectangle, but that's why I did it as this vertical shape. The only thing I couldn't figure out was how to then mirror that exact same rectangle along the z-axis. I wanted to like clone it and mirror it, but I wanted the mirrored version to be a permanent clone of the original. So if I changed the parameters of the original, the mirrored one would change. I couldn't figure out how to do that. So I just had to copy it. And then if I had to change the original, I had to change the copy. Super annoying and kind of violates all that convenience of it being parameterized design. So I'm sure there is a way to do it. I just couldn't figure it out. And because it was just a rectangle, it worked out. So I did it on that face and then on this face. And then I extruded as a cut in both directions. And that's it. That's how I made it. So we can see through the history of my actual one. We can jump into the sketch here. You can see all the dimensions that I ended up putting in there. So each of these sort of steps in the stairs that go up and down, I measured what they are, and then also the diameter for each of those. And those are the only constraints, or the only dimensions I needed to put in. And then in the very end, I measured from top to bottom. Now, I didn't put a constraint from the top to the bottom because it surely wouldn't have added up with all of these other ones because of margin of error on all these measurements. But I did sanity check it by testing it end to end, and I was only like a 1/4 millimeter off, and that was certainly close enough. And so, if it was way off, I would need to double check all these measurements. But it kind of was a good way of sanity checking that all of these were correct. So I did the sketch. I rotated it, or whatever. What is it called? It's called revolving. I revolved it around that axis. I filleted the top so you get that nice little, easier insertion. And then I created the sketch along these two axes for that. I don't even know what you would call it. The two cuts in the top. And then I extruded in one direction, and then I extruded from the other cloned one in the other direction. Extruded as a cut operation. And then I just printed it, and it worked. I only had to print 2 of these. The very first time I'd forgotten this little bump here, so the whole thing was too short, and that made this part here that is actually what holds it in place didn't line up. So then I did the second one, and it worked. This was printed in PLA as just because it's what I already had in, and it's easier to print. And once I was sure the fit was good, I actually stuck it all the way in and just used a hammer to pull it back out. Then I printed in PETG, which is much stronger and heat resistant because it's going to be outside and it's going to take a lot of abuse being on that garbage can. And then it worked. So that's how I did this. Again, I'm far from an expert, but hopefully that might help you kind of get some of the basics. But that main thing that I now think about when I'm trying to make something from scratch is I try to visualize what would I sort of draw and then extrude or revolve and then cut to make it. Because if I can kind of imagine the basic operations before I get started, I'm going to be in a much better workflow to get it done. So I hope that was helpful.